Hi everybody, today we're going to talk about how to find the volume of a composite figure. When we talk about a composite figure, composite really just means a combination of more than one thing, more than one element. So when we're talking about it, in this case, composite figures are really just going to be more than one rectangular prism, and we're going to stick to rectangular prisms. If you look at the shape to the left, we can see there's a top figure and a bottom figure. So I like to think about it, if you had blocks that you were building with, you could build this shape pretty easily. So the top figure, if you remember the volume formula of a rectangular prism, is length times width times height. So we've got a length here of 10. It doesn't show us clearly, but I'll tell you how I got that in a moment. It has a width of 15 and it has a height of 10. Now, if you look carefully at these two figures, you can see that the top figure is sitting on top of the bottom figure, and they line up perfectly in the front and the back, so that means they have the same length. So if the bottom figure has a length of 10, then the top figure will as well. So that's where that 10 came from. Now, you always want to remember to show your work over on the side, but when I do 10 times 15, I get 150. 150 times 10 gives me 1,500 cubic inches. Remember that volume is always expressed in cubic units, and since we're dealing with inches, it's going to be cubic inches. Let's take a look at the bottom figure. The bottom figure also has a length of 10 inches, and that is clearly labeled. It has a width of 40 inches going across from side to side, and then it has a height of 10. And for that figure, they're clearly labeled, so that's no problem. I'm going to actually label bottom figure so that I can keep it straight from the top figure. I don't want to confuse this information. I again start with the volume formula of length times width times height. When I plug in that information, length of 10, width of 40, and height of 10, and then do the computation, 10 times 40 is 400. 400 times 10 is 4,000. Because it's volume, it's cubic. And because we're dealing with inches, it's inches. So I've got 4,000 cubic inches for that bottom figure. Now to find the combined volume of the entire composite figure, I just have to add those up. And again, I'm going to clearly show my work. The top figure volume is 1,500 or 1,500 cubic inches. The bottom figure volume is 4,000 cubic inches. When you add those together, you get 5,500 cubic inches. So that is the volume of this entire composite figure. And sometimes they don't show you the dimensions very clearly, and you have to just look very carefully and figure out how to determine what the new dimensions are or the unlisted dimensions are. So this is going to be the composite figure that we're going to use on the next problem, but I want to talk about it for a moment. You see that there's a left rectangular prism and there's a right rectangular prism. The first dimension I want to talk about is the height. You can see that the left and right figures are both the same height. So if it's listed as 7 inches on the left figure, there are 3 other places in this composite figure that are also going to have the same height. You can clearly see that the left and right figures have the same height. So if it's listed as 7 inches in one spot, then you know that it's 7 inches in the other spots. Now you can certainly label 7 inches every place that you see one of these verticals, and I do encourage people to do that, but just keep in mind that sometimes that gets a little bit crowded. If I look at the length of the left figure, that's 6 inches. And I also notice that right across the figure here is also 6 inches. Now that's going to come in handy in a moment, and I'll explain that. When we look at the right figure, we see that it has a width of 7 inches. If you look straight up above the labeled section of 7 inches, you see that this is also the same length. It's the opposite side on this face, and that is also 7 inches. And then we look to the back of the right figure. This will also be 7 inches. Again, looking at the right figure, we see this has a length of 10 inches. From the front to back, it's 10 inches. If you look directly above that, this will also have a length of 10 inches, as well as this. If we look at the total width of both rectangular prisms, we get a width, a combined width of 20 inches. So now let's see what the problem is going to look like when we break this down. I'm going to talk about the right figure first. Again, we're going to use the volume formula of length times width times height. This clearly has a length of 10. It has a width of 7. And if you remember, we just talked about if the left rectangular prism has a height of 7, then the right rectangular prism is also going to have a height of 7. And that's only because we can clearly see that they are the same height. So my dimensions of the right figure are 10, 7, and 7. When I multiply 7 times 7, I get 49. And then 49 times 10 gives me 490 cubic inches for the volume of just the right figure. Now let's look at the left one. The left figure has a length of 6, that's clearly labeled. It has a width of 13. Now that's not labeled, so we're going to talk about where that number came from in just a minute. But it does have a clear height labeled at 7 inches. So the 6 and the 7, like I said, are clearly labeled, but let's talk about where that 13 came from. A moment ago, I mentioned that the combined width of the two figures is 20 inches. If I know that the width of the right figure is 7 inches, remember this is 7 inches, it's labeled, but this is 7 inches and this is 7 inches as well. So if 7 of those 20 inches are from this point to this point, then to find what's left of the 20, all I need to do is subtract that 7 from 20. So that 20 inches across the whole back minus this 7 will give us a width of 13 inches right there. So that's where that came from. Again, show your work on the side. 6 times 7 is going to give us 42. 42 times 13 will give us 546 cubic inches. And once again, once we know the volume of each one of them, all that's left to do is combine them to add them up. So the right figure has a volume of 490 cubic inches. The left figure has a volume of 546 inches. And combined, or added together, we get a combined volume, or a total volume, of 1,036 cubic inches. Our last example, you see I've labeled them figure A and figure B. And honestly, it doesn't really matter what you call them. I do encourage you on your work to label them in some way that's meaningful to you. I could have called this the front figure and this the back figure, but again, it doesn't really matter. I'm calling this one figure A and figure B here. So if we look at figure A right there, figure B is in the front. I'm going to start with figure A using the volume formula of length times width times height. Figure A has a length of 4, clearly labeled. It has a width of 15 that is also clearly labeled, and a height of 1, so that's not bad at all. We didn't have to do too much work to figure that out. I encourage you to not do any of this work in your head. It's easy to make careless mistakes that way. Again, I always encourage you to also start with a formula and then just plug in that information right underneath. So the length is 4, the width is 15, and the height is 1. When I do 4 times 15, I get 60. When I do 60 times 1, I get 60 cubic feet. So that is a volume of figure A. When we look at figure B, it's showing that there's a length of 4. So from here to here would be 4. Now that's not labeled, but we're going to talk about that in a moment. It has a width of 8. That's also not shown. We have to figure that out, and I'll talk about that in a moment. But we do know that the height is 1 because that's the same as the height of figure A. So let's talk about the length of 4. What we can see is that the length the combined length of figure A and figure B when put together is 8 feet. So we can see from the front all the way to the back here, that's a combined length of 8 feet. Now if we look at figure A, we see that has a length of 4. So remember that goes all the way over to here too. So if one side is 4, then the other side is also going to be 4. So if we know the combined length is 8, and we know that figure A's length is 4, all we need to do is subtract that 4 from the 8. So 8 minus 4 gives us 4. So that's where the length came from. We're going to use that same kind of strategy to figure out the width of figure B. It's not labeled here, but we can see the width of figure A is 15 all the way across the back. We see this section of figure A is 7. What I want you to notice is if we put this section of figure A together with this section, together they're going to equal 15 because this entire section is going to be the same length as the back there. So figure B's width is just represented by this dotted line right here or this section right here. So if we know it's 15 all the way across the back and we're just going to subtract out this section, 15 minus 7 gives us 8 feet remaining. So that's where the width of figure B comes from. So again, we've got a length of 4, a width of 8, and a height of 1. When I do 8 times 4, I get 32. I do 32 times 1, I get 32 again. It's volume, so it's cubic units, and we're dealing with feet, so we have 32 cubic feet total there. When we look at the volume of figure A at 60 cubic feet and the volume of figure B at 32 cubic feet, all that's left to do is to combine them. So 60 plus 32 equals 92 cubic feet. So that's it for finding the volume of composite figures. See you next time, everybody.